Okay, here I have the memory chip um, program. So here, looking at um, the drawing that I made, you have you start off with a DMUX four-way, which the load bit is inserted into. That comes from the CPU, and based on the um, 14th and 15th bit of the address, which in this case would be 1314 on HDL since it starts from 0. It would either select the RAM, um, it would either go to the RAM, it would go to the screen, and it wouldn't go, here's nothing because the keyboard doesn't accept an input. So for the RAM, it would pass into, since there are two selections here, um, it would pass through an OR gate, and it would come out into the next load bit for the RAM 16K. Here, the in is for the input, a 16-bit value, and the address here would be the 0 to 13th bit um, of the address value, and RAM takes that's the size of the amount of bits that the RAM 16K takes, and then we'd have the output coming out again to a MUX, a four-way MUX, and again that would be two spots for the RAM out here, and then you'd have the output. And same thing with the screen, depending on the 14th and 15th bit, we could select the screen, which would go into the screen memory map, and again it would select the 0 to 12 address. That's how many bits it takes for the screen here. And then you would have the input coming in here, and it would be coming out into also the MUX four-way, and and then it would have the output depending on which selector it is. And again, for the MUX, it would also be the same as the selector for the DMUX, which would be 13 and 14, which is the 14th and 15th bit as well. And the keyboard, it doesn't have an input, just has an output, and that will go into the last MUX here, and then again would be an output. And that's the memory chip. Now, unfortunately, I wasn't able to complete the CPU part of this lab. I did try, and I was getting pretty close, but unfortunately, I wasn't able to complete it. So I'm skipping over to the computer chip, which is very easy. Basically, I just used the diagram that's in the book here. That's basically all you really need. Basically, you just have the reset is it's the input coming into um, the computer chip, and it's going into the CPU, and then yeah, pretty much. So you have the instruction coming into the from the ROM. You have the reset, and then you have the in M that's coming from the memory, and which pretty much is the the memory location, the value of the memory location. And then the output, you have the write M, which basically becomes the load bid for the memory, whether to write or not. And you have the out M here, which is which is the value for the memory, and then you have the address for the memory. Get the output here, and then you have the loop here that's created. And down here you have again the reset that decides if the CPU will reset or not, and you have the PC here, the program counter, which stores the instructions for the next clock cycle. And that's pretty much it. You just pretty much just combined all three chips, and yeah, very simple. Now, unfortunately, I wasn't able to create the CPU, so I'm not able to test this program, but I'm fairly certain that it would work if I was able to do so. Here I have the program input for the memory chip, and so I have to use the screen here. Okay. So I can see it did work for the memory chip. And again, I wasn't able to do it for the CPU, and since I don't have the CPU, I wasn't able to test the computer chip program, but again, the computer chip was pretty simple, and if I did have the CPU, then this would definitely work.